Let's take a look at this example. Anytime you are going to have limit of the difference of two square roots, you're supposed to first convert this expression to fraction. Simply write this as limit with x going to infinity, and in the numerator you are going to have 2x squared plus 1 minus square root 2x squared minus 3 over 1. Next, in order to eliminate the square roots, I have to multiply the numerator and denominator by the conjugate of my numerator in this case. So I have times, I have square root of 2x squared plus 1 plus, because this has to be conjugate, and I have 2x squared minus 3 over 2x squared plus 1 plus square root of 2x squared minus 3. Look at the numerators. In the numerators we have nothing else, just the difference of two squares. Let me remind you the formula. A squared minus b squared is equal a minus b times a plus b. So this is my a, this is my b. This is a, this is b. I can rewrite this as limit x goes to infinity, and I have square root 2x squared plus 1 to the second power minus square root 2x squared minus 3 to the second power over denominator, which is square root of 2x squared plus 1 plus square root of 2x squared minus 3. You can rewrite this as limit with x going to infinity, and in the numerator, please notice, this exponent is going to eliminate this radical, and let's say this power is going to eliminate square root, and I'm going to have 2x squared plus 1, and I have negative times positive 2x squared is negative 2x squared, and I have negative times negative 3 will give me positive 3. In the denominator, I'm going to have square root of 2x squared plus 1 plus square root of 2x squared minus 3 equals, organize the numerator, and we are going to have limit with x going to infinity, and we have 2x squared minus 2x squared that are going to subtract each other, and I have 1 plus 3 is equal 4 over, now from these two terms we can factorize the x squared under the radical, which is simply x squared, and I have 2 plus 1 over x squared plus square root, and I have again x squared, and inside of the parentheses I'm going to have 2 minus 3 over x squared. I can rewrite this as limit with x going to infinity, and this is 4 over, I have square root of x squared times square root of 2 plus 1 over x squared plus square root of x squared times square root of 2 minus 3 over x squared. Next, I can factorize square root of x squared, and we're going to have limit with x going to infinity, and I'm going to have 4 over square root of x squared times, and I have square root of 2 plus 1 over x squared plus square root of 2 minus 3 over x squared. Please notice that we have got square root of x squared. Square root of x squared is equal absolute value of x. And because x is going to the positive infinity, I'm going to simply, instead of write absolute value of x, just x. I'll have limit with x going to infinity and 4 over x, and I have square root of 2 plus 1 over x squared plus square root of 2 minus 3 over x squared. Okay, and this is going to be equal constant divided by x, which goes to infinity. This fraction will approach 0. And constant divided by x, where x goes to infinity, this is going to approach 0. Okay, so now we have constant in the numerator and x goes to infinity. That's why the whole fraction, the whole answer, is going to approach 0. And 0 is the solution to my problem.